This is the Chapter 3 assignment video, and what we are doing is we are working with probabilities. So we have a bag that contains the following marbles. We have 5 blue marbles numbered 1 through 5, 4 red marbles numbered 1 through 4, and 3 green marbles numbered 1, 2, and 3. So we are randomly selecting one marble, and that's important to note that we're just drawing out one marble. And we want to find out what's the probability that it would be red. There's a total of 12 marbles, and of those 12, there's 4 that are red. So 4 divided by 12, rounding to 2 decimal places, is 0.25. The next problem is, what is the probability of getting a red marble given that we know that it's a 3? So first, we're just considering that we're only looking at the marbles with the number 3 printed on them. So there's 3 of those, these 3 marbles right here. So there's 3 marbles to select from. Of those 3, there's only 1 that's red. So the probability of getting a red marble, given that it's a 3, is 1 divided by 3, rounding to 2 decimal places, is 0.33. The next problem is, what's the probability of getting a marble that is not blue? The bar over the word blue means not blue. So there's a couple of ways we could do this. The first would be to count all the marbles that are not blue. Well, that would be these 4 red plus these 3 green marbles. So that's a total of, well, there's 12 total marbles, and there's 7 that are not blue. So 7 divided by 12 would be 0.58, rounding to 2 decimal places. Now I want to show you one other way that you could do this. You saw in the notes where we learned that the probability of something not being blue is equal to 1 minus the probability that it is blue. And we know this because the probability of a marble being blue plus the probability that it's not blue is 100% chance. It's either one or the other. So if we take 1, which is like 100%, subtract the probability of getting a blue marble, that's going to give us the probability of the marble not being blue. So 1 minus the probability of getting a blue marble. There's 12 marbles and 5 are blue. So if you do the math here, I'm going to just take the time to show you how to do this on the TI calculator. I'll show you how we can get that answer. So if we do 1 minus, and when I see a fraction, I'm going to put it in parentheses, so 5 divided by 12, and close off those parentheses. It's going to give me this decimal of 0.58, rounding to 2 decimal places. Now there is a feature on your calculator I wanted to show you. If you click the math button, you hit enter for fraction and enter for your answer, and it writes the decimal as a fraction. Okay, going back to problem D, we're asked to find the probability of getting a marble with a 4 on it given that it's blue. So here we're only looking at the blue marbles. There's 5 marbles that are blue, and of those 5, just 1 has the number 4 printed on it. So 1 divided by 5 is 0.20, rounding to 2 decimal places. The next problem here, what's the probability of getting a red and a 4? Now this and right here, we have to remember that we're only taking out one marble. So basically it's asking, what's the probability of getting the red marble with the 4 on it? So there are still the 12 marbles, but there's only one marble that's red and a 4. That's this marble right here. It's the red 4. The probability there, the probability is 1 divided by 12, which is 0.08, rounding to 2 decimal places. Now we are changing to, we're still just selecting one marble, but we're using the word or. So we're trying to find out what's the probability of reaching in and getting one marble that it's either blue or it has a 2 on it. So the way that we do that is, the rule is it's equal to the probability of getting a blue plus the probability of getting a marble with a 2 minus the probability that the marble is blue and has a 2 on it. So let's see what that works out to be. The probability of getting a blue, there's 12 marbles and 5 of them are blue. Probability of getting a 2, there's 12 marbles and 3 have a 2, minus how many marbles are blue and 2, and that's just this one right here, this blue marble with a 2 on it. So there's one of those out of the 12, and we can put these in parentheses if you want to. You don't have to, but if you're doing this on the calculator, you would want to do that. If you work that out, in fact, I'll just show you how to do this on the calculator. If you clear this off here, you would just simply put all your fractions in the parentheses. So 5 divided by 12 plus 3 divided by 12, 3 divided by 12, minus 1 divided by 12. Closing off those parentheses and enter. So there's the decimal we get is 0.58. Now in your homework it may also ask you for a fraction, and the way to do that is to hit your math button and then hit enter and enter. 7/12. Alright, so 0.58 or 7/12. Either answer is fine here. For this next one, we're trying to find what's the probability. We're still just reaching in and getting out one marble. But what is the probability that this marble is green or 3? So that's the probability of getting a green plus the probability of getting a 3 minus the probability that we get a marble that is green and has a 3 on it. And so that's going to be the probability of getting a green. There's 3 that are green out of 12 plus probability of getting a 3. Well, there's 3 marbles with the 3 out of 12. Whoops. Minus the probability of getting a marble that is both green and 3, and there's one of those out of 12. So doing this math, you get 0.42. Just leaving it as a decimal rounded to 2 decimal places. Shifting gears just a little bit, we are now looking at reaching in and pulling out 2 marbles. So let's look at the first one. The probability of reaching in and getting a blue and then drawing out a red. So this is equal to the probability of getting a blue times the probability of getting a red. Now we have to think about, are we using a replacement or not? So this is without replacement. We are not putting that first marble back in the bag. So the probability of getting a blue, there's 12 marbles, 5 are blue, times, now there's only 11 marbles because we didn't replace that first one, and there's 4 that are red. So doing the math, you get 0.15. This is also and probability, so we're going to multiply those two probabilities together. So we're looking at the probability of getting a green times the probability of getting a green. And that's equal to, there's 12 marbles, 3 are green. We did not use replacement, so now there's only 11 marbles in the bag, and there's only 2 green ones because we already pulled out 1. So doing the math here, you get 0.05. Now we're working with problem 2. So we have this chart, and this is all the different military service divisions, and then we have that broken up into men and women. So I went ahead and totaled all this for you. So I totaled all the Army, all the Navy, and then I also totaled it this way. So I totaled up all the men in this group, and I totaled up all the women in this group. So we want to look at, again, this is important, we're just going to pull out one person from this group, and we want to know what's the probability of getting a woman. There's a total of 553 people in this group, and of those we have the total for the women is 173. Doing the math, 173 divided by 553 is 0.31. The next one asks, what's the probability of selecting a Marine given that we know this person is a man? So we're only looking at the men. If you total up all the men, there's 380 men. Of those, only 40 are Marines. So 40 divided by 380 is 0.11. The next problem, what's the probability of selecting someone that's not in the Army? So we still have the 553 people, but we're going to total up everybody that's not in the Army. So if we total up the Navy, the Air Force, the Marines, and the Coast Guard, we add all those together, we get 383. Dividing that out is 0.69. This one is the probability of selecting a woman given that we know they're in the Navy. So the total for the Navy, there's 115 total people in the Navy, and of those people, 34 are women. So the probability of selecting a person that is a woman, given that they're in the Navy, is 0.30. The next question, what's the probability of selecting a person that's a woman and also in the Coast Guard? So now we're just selecting one person. So we're only looking at how many people are women and in the Coast Guard. So here's my women. Here's the total that's in the Coast Guard. So that's 16 out of the total of 553 people. So that's only 0.03%. The next problem is we're looking at this or statement. So we want to know what's the probability of selecting someone, the Air Force, or selecting someone that's a man. So here that's going to be equal to the probability of selecting someone in the Air Force plus the probability of selecting a man minus the probability that this person is in the Air Force and a man. So the probability of being in the Air Force, there's 553 people. Of those in the Air Force is 155. Okay, plus the probability of being a male, there's 553. And of those men, there's 380 are men. Minus, we're going to subtract out the people that are both in the Air Force and men. So we still have the total of 553 people, but here's the men, and this 96 is the number that are in the Air Force. So doing this math, if you did this in your calculator, be sure to put those in parentheses, and you get 0.79. The probability of selecting a woman, one person, and that person is a woman or in the Navy, it's going to be the probability of selecting a woman plus the probability of someone being in the Navy minus the probability that the person is a woman and also in the Navy. So that's equal to the probability of being a woman, 553 people. There's a total of 173 women. Plus the probability of being in the Navy. That total is 115. Minus, I need to see how many people are women in the Navy. So that number, here's our Navy people, this is the number of women. So that's the 34 out of 553. Doing that math, we get 0.46. And lastly, we are looking at selecting 2 veterans out of this group. Let me slide this up. I'm going to have to move my paper around a little bit. So what's the probability that we pick out someone, they're in the Army, and then we pick someone else again, and they are in the Army? And this is without replacement. And we are pulling out 2. So let's see how this is going to work. We're going to multiply those probabilities together. Because think of this as probability of being in the Army and selecting somebody else and being in the Army. So this is an and statement, which means we multiply our probabilities together. So the probability of in the Army, 553, and looking up here in the chart, there's 170 in the Army, okay, times, now this is without replacement. So now we only have 552 people to choose from, and there's only 169 left that are in the Army because we already chose one of them. So this is multiplication. Multiplying these 2 fractions together, we get 0.09. And the last problem is, what is the probability of drawing out a man and then selecting a woman? And this is with replacement. So we will still multiply those probabilities together because this is an and statement, and it's 2. We're selecting 2 veterans. So we have 553 people total, and of those, how many are men? We have 380 that are men. So 380. And this is with replacement, so we put that person back in the shuffle, so there's still 553 people, and now we want to know how many women, so that is this total here. The 173 is the total for the women. Doing that math, we get 0.21.